SEIA has sent to us. There's a number of other things that can be done as well. There's a whole zonal analysis that you can do, and here's a zonal analysis looking at zones of the green area in the middle where you could put as high as a 40% penetration level, and then out at sort of the yellow-green at 25%, and then the outer rim at 15%, doing an actual system analysis. And so there's really three approaches that this paper uses to looking at how to analyze a distributed PV in a local distribution system. The first approach is the one I mentioned, which suggests utilizing PV-specific screening criteria that would utilize minimum daytime load for a circuit rather than the absolute minimum load or percentage of peak load. Second approach is applying additional screens to evaluate potential voltage or unintended islanding. And the third one is increased penetration levels in specific areas and zones like this slide shows, based upon substation location, circuit design, and existing DG. This is going to be much more difficult to do and much more sophisticated, but if we start developing the tools now and start developing the software necessary to have utilities have this in their pockets so they can start doing these analyses, we can then optimize the amount of DG that ultimately is allowed to be put in a distribution circuit. And we don't want consumers to start running up against this wall, because if they are, it's going to have a very negative impact on the industry. And that's something that we want to avoid. We want to be able to facilitate the installation of these systems as quickly as possible. And so we don't want this to be a problem, but if we don't address it now, it is going to be a problem in the future, given how quickly we're